Okay, everybody, good afternoon. I hope you guys are doing well. Give me a like, so we can see or determine if you guys can hear me. Hopefully, you can. So let's get those likes coming in. Anybody? Because what we want to do is actually check. There we go. We want to check the browser. Let's see how good our internet speed is today for you guys, okay? See if you guys can beat the morning classes. So that's kind of funny. It went like a really quick dip. Anyway, it's very good download speed, by the way. It's about 90% approximately of a gig, and that's great. And I would say that's very good upload speed. So you guys are in good shape. Set your settings to HD to maximize your experience on YouTube. And we're going to continue where we left off yesterday. But, before I do that, let's go to the class. Here we go. Let's go to Math 241, and let's see if you guys can see some of these things. I'm going to go to your schedule, and you can see down there, hopefully you guys can see some of this, right? So tell me, what do you guys have on Monday, December 7th? What's on Monday, December 7th? What do you have? You guys know? What does it say? Something special is happening. Anyone? Thank you. Okay, thank you, Casey. Thank you, Chloe. Thank you, Werner. You're absolutely right. Test 4 is on Monday, okay? Now, what I'm going to do here for you guys is I'm going to make your test 4 a take-home test. I'm going to write this stuff down. So test 4 is going to be a take-home test for you. And I will get that up on Monday. We're still going to have class on Monday. I want the class time, really. So the reason I'm giving you a take-home test is so I can have the class time. And so on Monday, yes, December 7th, we'll have a take-home test. It'll be due the day of your final. So you say, oh, okay, I'll have this due the day of my final exam. Yes, I will. Now, when is your final, ladies and gentlemen? Could you see that schedule? Can you see that information down there when your final exam is? Final exam is Tuesday, December 15th from 9:30 to 11:30 a.m. So that's the day of your final exam, Tuesday, December 15th. So, ladies and gentlemen, let's write this stuff down. Test 4. And we got to write it down so you guys can see this. Test 4 is on Monday. Now you say, what's Monday? December 7th. And is take home. Okay, so it's take home. It is due the day of your final. Which is on Thursday, or no, not Thursday, it's actually Tuesday. December 15th. Homework is still due on Monday, 12/7, and that's really homework 4. So your homework is still due. So I want to let you guys know, here's some important points, and we're still going to have lecture. I'm going to say we will have lecture on Monday, 12/7. So you're still going to have lecture, ladies and gentlemen, but you'll have a take-home test. And so that's kind of what's going on now. So hopefully you guys will be clear about what's happening. Test 4 is on Monday. It's a take-home test. And take-home homework 4 is still due on Monday. So we don't want you to procrastinate. Okay? We want you to be ready for finals week and ready to take your final. That test 4 we do on December 15th, the day of your final. So Tuesday 15th, this is when it's due. So this is the important things. Anybody have any questions on that? Anybody have any questions? Okay, you guys are good with that? Okay, looks like you're good. Okay. Now. All right, so I guess we could begin now. So let's go back and begin here on what we finished with last time. So I want you guys to remember this picture. We finished with this picture. And I'm going to give some details about this picture because there's a relationship. And so here's a fact. We have a relationship between polar coordinates and the rectangular coordinate system. Okay, polar coordinates we learned yesterday. You got this r theta to represent a point. We rotate the polar axis. I guess you can't see that, but I'll write it down over here. Here's what I'm saying. Yesterday we seen this r theta, where you take a pole, you got a polar axis, and then you rotate this, polar axis here. To some point P. Now let's remember this. Here's P. You have this R and you have this theta. So here's a distance R and you have this angle here, theta. It's a standard angle. So we seen that yesterday. So this is the polar coordinate system. And then I said, what we're going to do, though, is we're going to actually superimpose the rectangular coordinate system on top of the polar coordinate system. Let's see if we could get a straight line there, hopefully. All right, that's nuts. We're going to move it. Okay, so let's see. iPad, let's not cut iPad. Let's actually draw this here. Okay. So here's the coordinate, r theta. And we seen, I'm going to do the following here. I'm going to draw this here and let you know on the Cartesian coordinate system, we have the following here. This is the x coordinate value and the y coordinate. So this distance down here we seen last time. This distance was cosine theta. And we seen this other distance here. Maybe we should change color it purple. Or how about this? Let's go back. And let's say you are orange like last time, and you are green like last time. These are the sides of your right triangle, because you have a right triangle here. And this is sine theta. So remember, this is also r theta for the particular point we're looking at right here. This is P. So you have this relationship here between polar and rectangular. Now you say, what's rectangular? That's the xy. So the rectangular coordinate system is also the Cartesian coordinate system. Those are points written as x and y. And simply the polar coordinate system, we know that's points written as r and theta. So you have that as r and theta here. So there's a relationship between these points. Let's write down the relationship. We seen last time, here's a fact. And this is about conversion, if you have to convert between polar and rectangular. You have to convert from polar to rectangular. And you might say, what is that? R theta, right, and xy. So let's write down these facts here. We know that x equals r cosine theta and y equals r sine theta. So we got this yesterday looking at, this is, remember, this is the x coordinate here, and this is the y coordinate. So this equals your y coordinate, and that equals the x coordinate. So this is what we're talking about. Just by using definitions of sine and cosine. Remember that? So if I said to you, we prove this, that cosine will be adjacent the x coordinate over the hypotenuse, which means if I solve for x, x is r cosine theta. Similarly, sine theta was y over r by definition, and solving for y, we got r sine theta. So there you go. So this is what we're looking at. So you're going to use these equations if you're going to convert. Now notice this. You need polar values. So I need an r value and a theta. I need an r and a theta. If I get those values, I get these x and y values. So this is one fact. This is how we start to convert. So they're going to say convert some of these points, like maybe 2 pi over 4 to rectangular coordinates, where you have a polar form, r and theta. So you want to be able to go back and forth. And in order to do that, you got to use your equation. You say x is r cosine theta and y is r sine theta. So you say, what's the value of r? R is 2, theta is pi over 4. R is 2, theta is pi over 4. So x becomes 2 cosine pi over 4, and y is 2 sine pi over 4. So the rest of this information is dependent on, do you even know the values of cosine pi over 4 and sine pi over 4? Right? So this is square root of 2 over 2, square root of 2 over 2. So you get x is 2 times the square root of 2 over 2. And that's simply going to be the square root of 2. Here we go. And y equals 2 times the square root of 2 over 2, which means y also is the square root of 2. So ladies and gentlemen, here's how you first start to convert. This is your first conversion. Okay, so let's take a look at this. And I want you guys to even notice a few things. What I'm going to do now here is I'm going to bring in the polar graph, because this is going to be an important detail. Sometimes we have some details to talk about and to work through just in going through this process. right? Here's what I'm saying. Notice what they first gave us. They gave us polar form, meaning 2 pi over 4. So if I consider the positive portion of the x-axis here as my polar axis, and I consider the origin as a pole, we're going to rotate that pi over 4, which is 45 degrees. And let me do that here. Let's do this. Doesn't seem to be happy. So here's my ray rotated pi over 4. That's the angle. But the radius value is 2. So you say, okay, I have to go 1, 2 units. Here you go. Something like that, okay? Now, this is not to scale. This is the point 2 comma pi over 4. We talked about how to do that yesterday. But in terms of the Cartesian coordinates, and maybe it looks a little bit closer to, let me keep that. I don't know what happened. I'm going to move this point because it looks like I'm pretty much too big. 1, 2, something like that. Remember, the x coordinates is square root of 2, and the y coordinates is square root of 2. Because we found those x and y values if we were given the polar form. So we rotated this ray pi over 4, and this is what I'm saying, that in the polar world, you have 2 pi over 4, and that's actually the same as, in all honesty, the square root of 2, square root of 2. But be careful. They're the same locations. We could put equal, but they're different, systems here. Okay, so this is my r theta, and this is the xy. So we converted polar to rectangular, the x and y values. So we're going to have to start to get used to, how this works. And that's an important detail. So we're converting, ladies and gentlemen. This is your first conversion question. And so there's a lot of interesting things to talk about here, in all honesty. There's some interesting kinds of things. So I'm going to have you guys try some, right? You're going to convert to rectangular because I find, again, you got to get this class engaged. If they say to you, let's convert, again, how about if they say, oh, what is this? Let's say -2, and then my angle theta is going to be, this is going to be rectangular. How about 5 pi over 6? Okay. And then maybe another one. Convert 5. And I'll say -pi over 3. Let's do some more. How about 3? You're going to convert 2. Not 2. Let's do something different. How about 3 pi for -5 minus pi over 2. Convert these. And you're going to convert to rectangular, ladies and gentlemen. And you might say, well, what did they give me? Well, these are all r thetas. R thetas, right? R thetas. These are all r thetas. And so I want you to use the conversion formulas that we found here. And we're going to talk about some details with this. Okay, so use those formulas and let's see what we get, right? You say, what do you mean? Well, x is r cosine theta and y is r sine theta. So I'm going to give you guys a few moments to try these out, to do some conversion, and let's see what you get. Okay, here we go. So for the first one here, we have x is your r value is -2, and you got cosine 5 pi over 6. The y value is -2. You got sine 5 pi over 6. So this is kind of, again, part of why you're taking this course. You know, you got to know what these values are, right? And really, here's the key. You have to have the reference angle information of really pi over 6, this portion here. And pi over 6, remember, is 30 degrees. So take a look. This is the pi over 6. We're looking for that. 30 degrees. So you want to remember what this is. Right, what is that? 30 degrees. So remember, you got 2, 2, 2. And you're going to bisect this. And that now means you got 1 here and the square root of 3. And this is where that 30 degrees is, if you guys remember. So cosine, and you're focusing on this triangle. I guess right here. Okay. So the definition of cosine of 30 degrees, if you guys remember, isn't that adjacent over hypotenuse? So this is the square root of 3 over 2. Now, this again is the quadrant 1 answer. 5 pi over 6 is going to be, what is that, right? So if 30 degrees times 5, that's 150. Pi over 6 is in quadrant 2. So double check, ladies and gentlemen. And you might say, well, why do I care? All students, well, right in here, this should be pi over 6. Isn't that 30 times 5 is 150? So sine's positive. Cosine's negative in quadrant 2. So sine is positive. So you can say, oh, I need to know sine. Well, what's the definition of sine? This will be 1 over 2. Sine's positive, but cosine is negative. So I'm looking at sine of 5 pi over 6. Cosine is that square root of 3 over 2 we just found. Now let's double check. I've been talking a bit too much, and that has to be negative. So cosine, here's what I'm saying here. Cosine is negative in quadrant 2, but sine is positive. And that's why you say all students take calculus. So notice that we're really working with this scheme heavily. And that now means my x-coordinate is negative times a negative. So x will be -2, negative square root of 3 over 2. Or x is simply square root of 3. Y is -2 times 1/2. So we can say -2 times 1/2, and you now have y is actually -1. So here's my coordinates. Square root of 3 comma -1. So ladies and gentlemen, this is how you handle question 1. Anybody have any questions on this one? No? Question 2. Question 2, you say 5 negative pi over 3, right? So x will be 5 cosine negative pi over 3, and y is going to be 5 sine. And that's pi over 3, not 5. Okay. What do you guys think we should use? What should we use when we're dealing ever with these negative angles? You guys remember? What's cosine? Is that even or is that odd? Cosine's even, so this is 5 cosine of pi over 3. And then this will be -5 sine pi over 3, because sine is odd, cosine was even, right? So you remember all those ideas we worked with throughout the semester? So take a look. Everything that we worked on this semester is coming into play here, right? Everything. Does that kind of sound right to you? Everything is coming into play? I hope. Now you say cosine pi over 3, isn't that 60 degrees? So double check. Now what I'm going to tell you guys here is, remember this here is 60 degrees. So we're going to use the same special triangle. And this is what I say to people. Most of this course, 95% of the course, is knowing just two special triangles, 45, 45, 90 and 30, 60, 90. So if you don't know that, I got to say to you, why? Oh my God. Okay. What do we need? Cosine 60. Cosine is adjacent. Here's my cosine. Adjacent over hypotenuse. 1/2. Replace that with 1/2. Okay. What is sine? Sine, ladies and gentlemen, was opposite over what? Hypotenuse for 60. Square root of 3 over 2. I mean, I remember doing this in the beginning. Do you guys remember that, or is it just me? Maybe it's just me. So x is 5/2. Y is -5 square root of 3 over 2. So the rectangular coordinate is 5/2, -5 square root of 3 over 2. So here's what you look for, ladies and gentlemen. So you're converting, and again, we actually do this conversion in some other courses. We work in polar form. You'll see coming Monday. And now we could do number 3, which is r is 3, right? Sure, Nick, I don't mind give you a couple more. Let's give you 2 more minutes then. Let's try that out. I don't mind that at all. Let's try this. See what you guys get here. Okay, let's try this out. We got r. R is 3. Theta is pi. So x will be 3 cosine pi, and y will be 3 sine pi. So you want to know what cosine pi actually is. I think that's -1. And sine pi is 0, ladies and gentlemen. So to share with you that this will be 3 times -1, and y is 3 times 0. So my x-coordinate becomes -3, and my y-coordinate becomes 0. So this is -3, 0. Double check. Is that right? Something doesn't seem right to me. I guess it is right. It is okay. Yeah, it seems exactly right. Good. This is actually the answer, ladies and gentlemen. You got these x and y coordinate value. Okay, let's look at the last one, 4 here. So we know 4 is going to be here. -5, -pi/2. So x will be -5 cosine -pi/2, and y will be -5 sine -pi/2. So I'm going to use the even and odd properties. Cosine is even. So I got that negative sign, right? So that's going to be cosine's an even function. So that means it's just cosine of pi. And then sine is an odd function. So let me highlight that. You get a minus a minus. So that means y would be 5 sine pi. Now, what's cosine of pi? This portion is right. Isn't that portion 0? And then sine 90 degrees, that's 1. So we'll end up with x going to be -5 times 0, which is 0. And y is 5 times 1, which will be 5. So this is 0, 5. This is my coordinates here. So you guys know, we know how to go back and forth. So anyway, ladies and gentlemen, here's kind of how we convert from polar to rectangular. Okay. Did I have an issue? Oh, is it negative? No. It's positive. You can actually double check. Let me see. -pi/2. Yeah, it's positive. So remember this over here. This is a negative sine pi/2. So if you said, what is sine -pi/2? It's minus sine pi/2 because it's an odd function. Remember that? The odd function properties. So now we have a minus times a minus makes this a plus. Yeah. And actually, if you said to me, what if I were to plot this, right? You have, this is again an x coordinate and a y coordinate. And they gave you originally polar coordinates, which is -5, -pi/2. Right? They're the same location. So if I remind you a little bit by saying here, I can draw a Cartesian coordinate system. And I can say also, let's actually draw this polar axis with our pole. We rotate -pi/2. Well, I know where that is. That's down here. Okay, so we rotated in the clockwise direction. So if my radius is 5, you might say, oh, I have to put 1, 2, 3, 4, 5. It is, but it's in the opposite direction right up here. Remember? Because my radius value is negative. And so that would be 5 units. So this is supposed to be, this length here is supposed to be 5. So 1, 2, 3, 4, 5, whatever. Now notice, isn't that in terms of your x and y coordinates, isn't that the location of 0, 5? And the answer is yes. So this point is the same as that point. So we converted. So absolutely, ladies and gentlemen, double check there. Okay, so this is where -5, this is how you plot a negative radius. It's opposite of that. So sure enough, that's the same location. Okay, so let me write that down. -5 negative pi over 2. So you are good. I want you guys to notice that we are accurate. But, remember that even in odd functions, because that's at play, meaning sine of minus theta is minus sine of theta, because sine, again, is an odd function. But cosine minus theta is cosine theta because cosine is even. So remember this. This is what we were using to help evaluate for negative angles. And like I said, this is kind of the little details that are so important, in math and science, the small details. So remember that detail. And then you might say, what if I want to go in the reverse? What if I want to convert? Here's the second portion. What if you want to convert rectangular to polar? And that's rectangular now. And, if I try to go back to this triangle somewhere, we started with, this thing. I want you guys to focus on, again, the geometry of this triangle. And you might say, do you use the word geometry? Yeah, the geometry of that triangle. What you know is that r squared is x squared plus y squared. That's Pythagorean theorem. We also know that tangent of theta, by definition here from trig, is y over x. Okay, double check. This is opposite over adjacent. So you get these two equations here by this right triangle. So let's write that down, because that's going to be how we convert really polar to rectangular. Or what did I say? Rectangular to polar, sorry. So let me do this. Let's kind of make it a bit more presentable. So here's this rectangular version here. XY, where we know the conversion formula is r squared is x squared plus y squared. We know that tangent theta is y over x. And of course, x could never be 0 because we can never divide by 0. This is going to help us get the r theta, the polar version. So we're converting now rectangular to polar. We're doing the reverse. And when you do the reverse, ladies and gentlemen, you have to be a little bit careful. So let's give some examples of conversion. They're going to give you, for example, they got to give you rectangular. So I'm going to say they're going to give you, I don't know if I want to start with the ones that you have to be careful with, but you're going to start with maybe something like, okay, let's say 1, -1. And this is going to be they're giving you the rectangular coordinates. Okay? So if we start with something like this, I'll say to you, well, what do? You're going to find r squared here. Look at this. This is what's happening. They're giving you the x and y values. So you plug in x, you plug in y, you plug in y, you plug in x. This enables you to find r and theta, because that's what we're looking for, r and theta. So if you plug in, and you can start with the first one and say, I know r squared is 1 squared plus -1 squared. And r squared is 1 plus 1, or r squared will be 2. What that means is r will be plus or minus the square root of 2. So you have two answers. Okay? We'll talk about this detail. And that's by using the geometry, or I should say algebra, called the square root formula. So we have square root formula here for algebra. Similarly, you have tangent to be y over x. So tangent of the angle now is y over x, which means tangent of your angle. What's your y coordinate? Your y coordinate is -1, and the x coordinate is 1, right over here, okay? And so you might say tangent theta will be -1, yes, and that's a trig equation. We solve trig equations, yeah. Don't get the general solution, ladies and gentlemen. Remember, tangent's negative in quadrant 2 and quadrant 4, I believe, right? All students, yeah, take calculus. So I believe isn't that 3 pi over 4 for one solution? And then you have another solution, right? Remember this? I mean, we've seen this over and over again. And again, this is why you guys are taking the course here. All students take calculus. So this angle here, tangent's negative in quadrant 2 and in quadrant 4. So remember how we get this. This is the reference, pi over 4. So this is theta being pi minus pi over 4, which gave us a 3 pi over 4. And here's your reference again. So this will be theta is 2 pi minus pi over 4. And you're going to find from past information that's 7 pi over 4 again. So we have 2 theta values. So you do have to be careful, ladies and gentlemen, when you're converting from rectangular to polar. So notice the information. I got 2 radius values. And then I have 2 angle values. So what's the answer? I get to give an answer in terms of r comma theta. What do I do with this information? Do you guys know what I'm talking about? What do we do? Sorry about that. Okay, it's kind of annoying. Well, here's what I'm going to say to you guys. You see this point 1, -1? In the rectangular coordinate system, 1, -1 is going to be where? Go to the right 1 and go down 1. Is that true? This is 1, -1. So the point is in quadrant 4, just by looking at the rectangular coordinates. Okay? Does that make some sense? And so if I said to you, just plot the point and see where it lives. And we're talking polar now. This ray. So I can express this really an infinite number of ways. R theta, I can say to you, will be, if I actually use a negative rotation here, right? If I said to you, you know what, I'm going to say negative pi over 4. Okay, you can do that, but then your radius is positive. It's positive square root of 2. And I just want to point that out. There's one way you can do that, because your location here, this is where you're at 1, -1 on the Cartesian coordinate system. I can also say, by the way, I can use a positive angle. I can say, why don't I just say my angle here is positive 7 pi over 4? And you rotated, 7 pi over 4. Isn't that also square root of 2? And I'll say, yeah, it actually is. So if I went back to the theta, what did I do? Yeah, I'm using all the information I know from trig. I have theta being 7 pi over 4. Here it is 7 pi over 4. And you say, but Mr. Judge, what if they told you theta is 3 pi over 4? What if you said, I want to use the 3 pi over 4 solution instead? So here's my 3 pi over 4 solution. And if you want to use that solution, what's your radius? I want to ask you guys, because you went through the solving a trig equation and you found two answers, 3 pi over 4 and 7 pi over 4. Here they are. 3 pi over 4, 7 pi over 4. Where is 3 pi over 4? It's right here. But if I use 3 pi over 4 for my angle, remember the point is where? This is in quadrant 4. What would your radius be if I used 3 pi over 4 as the angle? Does anybody want to tell me? What do you think that radius has to be? Has to be negative. You say why? Because if you plotted this point, the location here would be square root of 2 comma 3 pi over 4. But the point is in quadrant here, quadrant 4. It's opposite. So that's minus square root of 2. Thank you. Outstanding, Alfredo. That's the way to do it. So you got to know these details so that you can actually compute these or plot these points. Now you might say, oh, is that why I have two answers? Yes. How many answers do you need to give? Only one. These locations are not well defined. They're not unique. So that's just a consequence of being periodic. Okay. But yes, minus square root of 2. So that's why he had two answers. So you have to put this together by plotting that point. And that happens when you go from rectangular to polar. You got to really see where that point lives, because you're going to get two solutions for r. You're going to get plus or minus. You'll get two solutions for tangent, because there's two quadrants where tangent's positive, and there's two quadrants for tangent's negative. So both r and theta have two solutions. You just have to go back to the original Cartesian coordinate point to find it. Whew. Okay, good. Yikes. Let's try that one out. Let's try another one. Wow. No wonder my voice hurts at the end of the day. Can't even talk sometimes. Okay, let's give you guys some more here. They're going to give us something like this. 3 square root of 3 and minus 3. Here's my rectangular coordinates, x and y. We need to convert to polar. What is r squared? You take 3 square root of 3 squared plus the negative 3 squared. So we're going to solve an algebra equation. And what is that? 3 square root of 3. Isn't that going to be, let me write this down just so you guys can remember some algebra. That's plus 9. 9 times 3 plus 9. 27 plus 9, which is 36. So, square root formula. R plus or minus square root of 36. R plus or minus 6. So here's my r value. And then you talk about theta. Tangent theta is y over x, right? So what's the y value? Negative 3 over 3 square root of 3, which is negative 1 over square root of 3. Okay? And you could do a couple of things here, I guess. Let's write this down. What do you guys remember if you have negative? Got to go to the reference angle. So I'm really glad. Remember, the reference angle is a quadrant 1 positive angle. And I'm really glad, ladies and gentlemen, that we worked with all those trig equations, because all of these ideas reinforce themselves on each other. Right? Reference angle and the definition of tangent. Remember this? So here's my right triangle. Here's the reference angle. What's the definition? 1 square root of 3. What did I say? All you need to know is two special triangles. And that's just too much to ask sometimes. What's the angle? Does anybody want to tell me here? This is the special triangle that should look familiar. This will be 2 by the Pythagorean theorem. So I'm saying to you, notice, only 2 special triangles. What would theta be? This is 60, and this is 60, and you have bisected here. Theta is 30 degrees, right? And that means it's pi over 6, 30 degrees. And that's just the reference angle. We've been working with this triangle since day 1. Okay. All right. Now you say, what about tangent theta, though? Tangent theta is negative. Well, that means it's in quadrant what? 2 solutions. All students, quadrant 2, take calculus. 2 and 3, or 2 and 4. 5 or 6. Okay, you guys with that? This is why you go through this all students take calculus stuff. Let's move that down. All students take calculus. So we said, what was this, 30 degrees? Okay, so quadrant 2. And 30 degrees, let me just kind of draw a little bit more realistic 30-degree angle. Here's 30 degrees right in here. This is what they mean again, right? And opposite that, 30 degrees. Remember we said tangent is negative in quadrant 2 and quadrant 4. Tangent's positive 1 in quadrant 1 and quadrant 3. So this means theta will be pi minus pi over 6. And theta will be 2 pi minus pi over 6. So my first theta angle is going to be 5 pi over 6. And then the second theta angle is 11 pi over 6. Okay, 2 angles, so we have to get both. So I have 2 radius values, plus or minus 6, and 2 angle values. So if I write this all down, let's write it down. My radius is plus or minus 6. There's 2 of them. And I got a theta being, 5 pi over 6. And a theta being 11 pi over 6. So we have to handle this situation. So here's what I'm going to say. How would you figure out? Let's try it this way. I'm going to put the solution for 5 pi over 6 and the solution for 11 pi over 6. Remember, we need an R value and a theta value. These are my 2 theta values. What would you say now? How are we going to go about now finding the right R value? What do you think we should do? How do we get R? Anybody know? How do we get R? You got 2 choices. They're right up here. Which goes where? One's positive, one's negative. Where do they go? Right? I'll put the answers here. So far, here's what I'm saying. This will be 6. This is 6. Which one is negative? How do you find that out? You got to go back to the Cartesian coordinate. You go back here. You see, where does this live? X and Y. Go to the left. Well, even if I went back to the prior, right? You go to the left 3 squared or 3 units and down negative 3. So you say you're going to the left. Let me double check. No, you're going to the right 3 squared or 3 units and down negative 3. Have it backwards over here. So this is 3. square root of 3, and this is going to be minus square root of 3. This point here is in quadrant 4. All right. So just like before, I'm going to say you have to rotate this distance, or I should say that's angle, 11 pi over 6. And if you do, your radius should be positive or negative. Do you guys know? It should be what? Right here. This radius distance should be positive. So for 11 pi over 6, it's a positive 6. And you say, what about 5 pi over 6? Where's 5 pi over 6? Well, if you rotate 5 pi over 6, ladies and gentlemen, you're over here now. This is that 5 pi over 6 solution. So for 5 pi over 6, you can't have a positive radius because you're in quadrant 2. The answer is in the opposite quadrant. So what do I put down here? Does anybody want to tell me? For 5 pi over 6, this is in quadrant 2, but I need a solution in quadrant 4. What's that value? What do you guys know? What's that going to be? Negative. So, ladies and gentlemen, take a look. This is how you handle converting from, different quadrants. Okay, anybody have any questions on this? This is important detail. So you might say, Mr. Judge, which one is the answer? Either. This isn't well defined. In fact, there's infinitely many solutions. You couldn't even list every solution. No, so Nick, you only need one answer. Okay? There's only a need for one. Because there's infinitely many solutions, I can take my angle theta and I can add any multiple of 2n pi and I get additional solutions. So I can do that for either angle because these are not well defined. This is a circle. You could keep going full revolutions, 2 pi, 1 revolution, 2, 3, 4, 5, multiple revolutions over and over again. And you're going to get, the same location. So they're not well defined. You only need one. And there you go. All right, ladies and gentlemen, so you get to convert. So you now say, if I said to you, let's give you guys one, and I think we're running out of time. But I see a nice one. What if they give you negative square root of 6? Negative square root of 2. Okay, this is Cartesian. We want polar. So, r squared, plug this in. Negative 6 squared plus negative 2 squared. It'll be 6 plus 2. R squared is 8. R is plus or minus the square root of 8. Now, if you guys remember how to simplify it, that's 2 square root of 2 for R, whatever. So here's my two radius values. And then I'm going to say to you, tangent theta is minus square root of 2 over minus square root of 6. Let's see what this is. Positive square root of 2 over square root of 6. Now, rationalize the denominator. I get square root of 12 over 6. Simplify this. 4 times 3, so that's 2 square root of 3 over 6, I believe. And that's the square root of 3 over 3. Interesting. Tangent theta is the square root of 3 over 3. Now remember, that's also 1 over square root of 3. So did I see that before? Tangent theta is 1 over the square root of 3. Yeah, I have. Tangent theta is 1 over the square root of 3. And say, what is that? See this here, my reference? Right? Right here, I'm looking at right here. I've seen this before. So just doing a little bit of algebra, I know my angle is 30 degrees. So it pays to know algebra. theta is 30 degrees. Now, there's two angles. We said pi over 6, right? Because all students take calculus. Tangent's positive. So tangent's positive in quadrant 1 and quadrant 3. So this will be pi plus pi over 6 for the second solution. So we get theta 1, and then theta 2 will be 7 pi over 6. So we only need one answer. Remember that. We only need one of these. Let me get rid of this. So which one is it? Now, I'm going to say go back to the curve. Minus, minus. I know I didn't draw a picture again this time for this one. But minus the square root of 6 over 2, minus a minus. It's to the left and down. So this way, go to the left. Let me get that there. Go to the left and go down here. This is minus the square root of 6, minus the square root of 2. And I actually, you know, I didn't want to draw the line yet, but I'm saying to you, that's this rectangular coordinate version, x-axis, y-axis. We're trying to find the polar version. So remember, we're going to rotate some angle. What is that angle? Because since we only need one solution, ladies and gentlemen, what's that angle? Do you guys know that's a quadrant 1, quadrant 2? That's a quadrant 3 angle. So between pi over 6 and 7 pi over 6, what do you think this angle will be? You got two choices. What are they? What do you think they'll be? Anybody know? Is pi over 6 in quadrant 1 or quadrant 3? Is 7 pi over 6 in quadrant 1 or quadrant 3? Where is that? 7 pi over 6. Thank you, Darian. So since we only have to give one answer, which should the radius be, positive or negative? Right? The radius is going to be now, since we, I guess whatever, what's the R values we got? 2 square root of 2? Yeah. So your radius is going to be a positive answer. So you guys know. You know. Because that's the location if you just rotate that polar axis again. Seven pi over 6. This location will be a positive radius value. And again, you only have to give one answer, and then that's fine. So I just want to let you guys know. Even though you say, well, what do I do with another one? Well, you know, if you said, but I want to use the other angle. Okay, if you wanted to use that other angle, there's nothing wrong with that. It's a solution. Say, I'd rather use pi over 6. That's a quadrant 1 angle. So quadrant 1, you know, like I said, they're saying this is that's the pi over 6. And then the distance, again, here, you're in the opposite quadrant, which means a negative radius value. So that's how you handle this polar situation, ladies and gentlemen. Okay, you made use of all those solutions. All right, okay. So what I'm going to add to your homework is questions on conversion, and this is going to be in section 8.1. You want to convert 25 to 40. And all of this is going to help you with the later work. So this is going to be additional in your homework. Now remember, what's happening on Monday? What kind of test are you guys having on Monday? Does anybody know? What kind of test? You guys are 241. What kind of test is happening on Monday? A take home. Thank you, Brandon. And then I'm going to say to you, do you have lecture on Monday? Right? Do we have lecture on Monday? Anybody remember? Okay, we got a good question. Hold on. Let me update this homework here. So I just updated your homework in Canvas. You should get the announcement. So, okay, we have a question. Do you have a study guide for the take-home test? The answer is no, because the take-home test is take-home. So, in other words, on what's date? Monday, you'll have access to it, and there it is. So it's a take-home test. We'll have a study guide for the final, but not for test 4, because test 4 is a take-home test. Okay. All right. You guys okay with that? So there's no use of putting a study guide for your take-home test. It's take-home. But there will be one for the final. So that's kind of what's going on. Okay. So anyway, it looks like we're out of time. If there's not any other questions, and remember, I'm saying too, you have a lecture on what day? You got a lecture on Monday. All right, print your name on the comment section, ladies and gentlemen. Have a great and wonderful day. I hope I was clear with everything and the questions that you guys have. So print your name, take it easy, stay safe, and, have a wonderful day. All right? Stay inside. Don't go anywhere. You're welcome, Peyton. You're welcome, Werner.